Solving multi-step equations. Recall that a solution is a value that makes the equation true. This is amazingly important because it means you can plug your solution in and check if your answer is correct or not. Now, when it comes to solving an equation, I like to generalize it into 3 steps, but for today, we're going to focus on this 3rd step, which is to isolate x. And the way that we isolate x is we undo what is happening to x, and something I want to point out is this reverse order business. So if you think about Unit 0, we learned about order of operations, which means that the original problem, likes to follow GEMDAS, right? So it will follow GEMDAS in terms of what the problem applies to x. So what we like to do is we like to undo GEMDAS. But when we're going to undo GEMDAS, not only do we need to use the opposite operation, we also need to do it in the opposite order. And if that doesn't make sense, we'll do some problems so you can see what I mean. So in exercise 1, first identify what happened to x, then undo in the reverse order to solve for x. So if we're following GEMDAS, do we have any grouping symbols? No. Exponents? No. Multiplication or division? Yes. We have division. So I'm going to highlight the 3 and write down that the first step that the problem did is it divided by 3. Then the problem subtracts 7. So first the problem took x and divided by 3, then the problem subtracted 7 from x. So for what this means is we need to undo in reverse order. So pay attention to the color coding. We need to undo the subtraction by 7 first, because we're going in the opposite order. Then, after we undo the subtraction by 7, we undo the division. So here's what this will look like then. Here's my original problem. First, we undo the subtraction by 7 by adding 7 to both sides. So this gives me x over 3 equals 5. And then we need to undo the division by 3. And so we undo division by multiplying. And so our solution is x is equal to 15. Now we won't do all of our work like this, but it's nice to write all these words out until you get into the flow of things. So for exercise B, we have 4x plus 3 equals negative 7. So we want to recognize under order of operations, the x is being multiplied by a 4 first. And then from here, it's being added by 3. And so when we're undoing, we start from the bottom and work our way to the top, and that's the order that we undo. So here's the original problem. 4x plus 3 equals negative 17. So first we want to undo the addition by 3. So we subtract 3 from both sides. Again, notice the way that I'm color coding. So on the left hand side, this gives me 4x is equal to negative 20. And now we want to undo the multiplication by 4. And so we undo multiplication by dividing by 4. And so on the left hand side we have x, and on the right hand side we have negative 5. Okay, moving on to part C, we have 8x plus 2 equals negative 2. So first thing to recognize is that x is being multiplied by 8. And then the second operation here is x is being added by 2. So we want to undo the bottom operation first and work our way to the top. So here's the original problem. 8x plus 2 equals negative 2. So first we undo addition by 2. And the way that we do that is subtracting 2 from both sides. And on the left hand side, that gives us 8x equals negative 4. And then we undo the multiplication by 8. And the way that we do that is we divide both sides by 8. On the left hand side, this gives us x. And on the right hand side, we have negative 4 over 8. But this will reduce to negative 1/2 because 2 will go into both numbers. And that's our solution to part C. Now part D is a little bit more complicated. We have x plus 7 all over 3 equals 2. Recall that when I first talked about fractions and orders of operations, I mentioned that a fraction is really a grouping symbol. What that means is it likes to group the x and the 7 because they're both in the numerator together. And the reason why this is important is because it changes the order of the problem. So here's what I mean by that. Because we follow PEMDAS or GEMDAS, what's happening is that the parentheses means that we're adding 7 as the first operation. So let me highlight. Because of the parentheses, x is added by 7 first. Then the 3 in the bottom is a division. Okay, well, in terms of undoing, we're going to do as we've been doing. We use the inverse operation, starting from the bottom and working our way to the top. So the original problem is x plus 7 all over 3 equals 2. So to undo division by 3, we'll multiply both sides by 3. Now what's going to happen is really we have a 3 in the numerator and a 3 in the denominator on the left hand side. Those will reduce each other out, leaving me with simply x plus 7. And on the right hand side we have 6. From here we want to undo the addition of 7 And so the inverse operation of that is to subtract 7 from both sides. And so on the left-hand side we have x, and on the right-hand side we have -1. Moving on to part F. Following order of operations. What is the problem doing? Well, the problem first has multiplication by 3/4. And then the problem subtracted 5. Okay, so what do we need to do? We need to undo from the bottom to the top. So the original problem, 3/4 times x minus 5 equals 4. So the inverse of subtracting 5 is to add 5 to both sides. On the left-hand side, this gives us 3/4 times x equals 9. And so this is where the previous lesson is really powerful. We need to undo multiplication by 3/4. And while we could say, hey, the inverse of multiplying by 3/4 is to divide by 3/4, I taught you a little trick. It's that we can simply multiply by the reciprocal of the fraction. So the reciprocal of 3/4 is 4/3. So what I can do is I can multiply the left-hand side by 4/3 and do the same thing for the right-hand side. Now while I'm at it, I'll also convert the 9 into a fraction. And remember, the reason why this is powerful is because on the left-hand side, since I have a number multiplied by its reciprocal, that will simply turn into a 1, leaving me with an x. On the right-hand side, we have 9 times 4 in the numerator is 36, and I have a 3 in the denominator, but 36 divided by 3 is 12. Exercise G is very similar to F, so I will skip that. Taking a look at exercise number 2, this is a more complicated problem, but it is a good one. So, if we follow order of operations, first we see a parentheses with the -3 inside the parentheses. So, the problem, the very first thing that the problem does is it subtracts 3. From here, we have multiplication by 5/8. And then next, the problem also adds 2. So now that we've written out what the problem did to x, we are going to undo. Right? Reverse them. So first, we undo the addition by 2. But let me write the original problem down. So first, we undo the addition by 2. So I'll subtract 2 from both sides. On the left-hand side, that gives me 5 times x minus 3 all over 8 equals On the right hand side, we have 5. Now that I've undone the addition by 2 in blue, I need to undo the multiplication of 5 over 8. And so the way I can do that is by multiplying by the reciprocal. So I will multiply the left-hand side by 8 over 5, and I'll multiply the right-hand side by 8 over 5. On the left-hand side, because all the fractional bits will undo each other, so I circled that in red. Everything I circled in red essentially turns into a 1, and that leaves us simply with x minus 3 on the left-hand side, and on the right-hand side we have 8, right? And if you can't see that, it's because I can turn the fraction, the whole number, into a fraction, and we have a 5 in the top and a 5 in the bottom, undoing each other, leaving us with 8. Okay, now next up, we need to undo the subtraction of 3 in green, and so the inverse operation is to add 3 to both sides, leaving us with x is equal to 11. And that's it for multi-step problems.